Hey friends, I'm Praveen, and in this video I'm going to talk about debugging in Visual Studio. Visual Studio has a lot of tools to help programmers with the debugging, and today I'm going to talk about few of those tools. So before jumping into the fundamentals, let's see what this program is about. So I have three functions: func, read and echo, and a main function. So read and echo is just a function that takes input from the user and then echoes it to the screen and stores the input in the argument that is actually a pointer to the variable. Okay, and I have another function func, which is pretty useless. It just has few printf statements, and then I just take the sum of a and b and I print it to the standard output. So that's it. So now I press debug, and instead of start with debugging or without debugging, I go to step into. So once I go into step into, you see a yellow pointer. This pointer is pointing to the next statement that is going to be executed. Okay, now I have two ways of going into next statement. I can press step into, which is located in this toolbar. So suppose if you do not have this toolbar, view, go to view, toolbars, and you can find debug. So here's a debug toolbar. So if you have the toolbar, then you can press step into either here, or you can go to debug menu and press step into, or you can also press F11, which is a shortcut. Okay, so let us press step into. So it went to the next statement, read and echo. Now if I press step into at this point, what happens is the control moves to the first statement inside this function, inside read and echo. So step into essentially means step into the function. If it is a statement, then the statement is simply executed. Okay, so let us get into the function step into. So you see the yellow marker. So this is the first statement to be executed. Step into, enter a value, again step into, step into. So because it is scanf, it is prompting me for an input. So I say 5. Okay, the next statement to be executed is printf. I say press step into, step into. So if you look at the output screen, you see both the printf statements were executed. Okay, now I say again step into. So I came into func function because this is being called from read and echo function. Now inside this function again I press step into. So I have 4 printf statements. So it is unnecessary to step onto every statement. So I have two options: step over or step out. So step out means I want to skip this function. I want to get out of this function and reach this the place where this function was called. So suppose I press step out. So you see now the control has passed to where the function was called, right? So this is step out, essentially step out of function. Now I say step into. So done with this function. Now similarly I can go to step into and read and echo, step into, step into, step into. It prompts for an input. I say 6 for example. Then step into, step into, step into. Now let me demonstrate what step over is. Step over is just simply skip this statement. Skip this statement instead of executing it line by line. So step over, step over, step over. So if you carefully look at this, step into and step over probably seem they are same, but they are not. I'll explain it. So if you take a look, step into is step inside the function, and step out or step over is more like I want to skip this function. Please execute this function as a unit. I don't want to you know, get into this function. So let us see how this works. I press again step into. Now the next statement to be executed is function, func. Now I don't want to go inside this function because it just has printf statements. So I say step over. So if you look at it, I didn't go into this function. I just went to the next statement, that is printf. But if you look at the output screen, of course, it executes. So basically, these step into, step over, and step out are just flexible ways of controlling the execution. So this ends the demonstration of step into, step over, and step out. Now let us look at locals. Okay, so before explaining locals, let us stop debugging. Stop debugging. Okay, so sometimes you want to supervise the local variables of any function. Like for example, in this main function I have two variables a and b, and in read and echo I have another local variable x. So these variables, you want to know how how the values of these variables are being changed. So in such a situation you can use the locals feature. Okay, so press debug, step into. So int main is the first statement to be executed. Step into. Okay, now I have two local variables a and b. So if you hover over this a, you see the value -8589993. So these are local variables, and they have garbage values because you have not initialized these variables with any value. But if you want a more proper way of viewing these local variables, go to debug menu, Windows, and press locals. So you also have a shortcut assigned to it, Alt +4. Either press that or press locals. Okay, so here you have a better view of locals, a and b garbage values. Now I press into the next statement to be executed is read and echo. So if you carefully look at it, you don't have a and b anymore because a and b are not local to this function. Rather, x is local to this function. So x has two parts. Because x is a pointer, x has its own address and x has its value as well. I mean the value of the variable to which this is pointing to. Okay, now I say step into, step into, step into. So it prompts me for an input. I say 5. So look at this. The value of x is address, but the variable which x points to has changed to 5. So that is what a pointer does, right? So step into, step into, step into. So now it goes into function. I mean, because read and echo has a call to function, so there is nothing inside this function, so there are no local variables. I can say step out. I just don't want to execute it. So now let me get out of this function. So at this point, after the execution of read and echo, I have value of a as 5, but the value of b is still garbage value. So let me get to the next statement, read and echo. Now instead of pressing step into, I can press step over. Now if I press step over, this whole function is executed as a single unit, so I don't need to go step by step. Okay, now it prompts me for a value. I say 8. I give 8 as a value. Now look at this. Value of b is now 8. So it is marked red. It is highlighted red because this is a recent change. The value of a is not red because this is not a recent change. Okay. Now the next call is function. I can just skip. I say step over, step over. So sum is 13. Then step over, and then done. I can stop debugging. Okay, so that is how you actually use the locals feature to supervise the values of local variables in every function. So next I'm going to talk about watches. Okay, so watches are just like, how watchtowers function. So you keep track of all the variables, not just locals. Whatever variable you want, you can keep track using watches. So let us try using it. So go to debug menu, step into, and I'm closing this locals window, and I go to debug menu, Windows, and watch. So I have 1, 2, 3, 4. I can maintain multiple watch windows. So let us start with one window. Okay, so let me clear the entries. Yeah. So the first statement is main. Now I want to keep track of A, B, and X. Okay, see, A and B are local to main, but X is not local to main. So let's see what happens. So I say A, B, and X. Okay, so as expected, A and B have some values, but X is not defined, is undefined, right? So step into this main function. So A and B have garbage values, and X is grayed out, meaning X is not local to this function. So I don't know the value of X. So if X was a global variable, then definitely you can see the value of X here. But X is local to some other function here. Okay, so I'll step over this function. So it asks for a value. I say 5. So value of A is changed to 5, and B is garbage value. Okay, now I say step into. So when I'm inside this function, you see that values A and B were grayed out, but value of X is now active. The variable X is active because X is local to this function, right? Now if I refresh A and B, see, identify A and B are undefined because they're not local to this function. Okay, now I press step out of this function, step out. So it prompts me for a value. I say 7 probably. So A and B were changed to 5 and 7, and again X is grayed out because you're out of this read and echo. Now I say step over. Yes, so sum of inputs is 12. Yeah, so when I was in main function, I pressed step out. So all the statements are being executed at once. So that's it. This is external code. Just don't look at this. Yeah, so that is it. So that is how watches work. So using watches, whatever the variables are, either locals or globals, you can keep track of them. Now I'll explain about stack traces. So let's try to re-execute this function. Step into. Okay, now just a second. Yeah, so I'm closing this watch window. Now press debug menu, Windows, call stack. Okay, so call stack has two frames currently. The first frame is some external code which is actually invoking this main function, and upon this I have a main function, the main function, right? Okay, so I say step into, step into. Now when I went into this function read and echo, a new stack frame was introduced. So I have three frames now: external code, main function, and upon it read and echo. So I say step into, step into, step into, some value 5, step into, step into, and step into. Yeah, so when I went into this function func, another stack frame was introduced: external code, main, read and echo, and then function. So every function every function call is introducing a new stack frame. Okay, so I just step out of this function because I know what it does. So when I press step out of this function, the stack frame popped out, right? So again I step out of this function, another stack frame popped out. So I step over, give some other value 6, now I say step into, a new stack frame was introduced, which is function, right? So if you carefully look at this top right, I can also look at the stack frames using this menu, this toolbar. So the first stack frame, the innermost stack frame, is external code, upon it is main, and upon it is function. Okay, so this is essentially what stack frames are. So now let us look at what breakpoints are. Okay, so breakpoints are like speed breakers. Essentially, they do not break speed, but they break execution of programs. So let us get to main function. So you can place breakpoints by clicking this grayed out bar. For example, I press here, so a breakpoint is introduced here. So what happens is, during execution, whenever a breakpoint is reached, whenever line 23 is reached, the execution is broken. Just like step into and step over worked, like pausing the execution, so breakpoint also works a similar way. It pauses execution at this point. Okay, so it breaks execution at this point. Now let us see. Instead of pressing step into or step over, I say start debugging. Right. So come on. Yeah. So you don't see anything in the output screen because the execution is still waiting for your command. Right. Now I can say debug and then step into, so I can go into this function. So breakpoints also give you another flexibility, so you can break execution wherever you want and then proceed from there. Okay, or you see people doing print debugging, like putting printf statements everywhere. Okay, so sometimes print debugging is helpful because you don't need to have much knowledge about debugging. You just put printf statements to see if control is passing to a particular block. But when you are working for big companies, you need to make sure that you follow a proper procedure. So breakpoints, that generally you don't need to change any code. You don't need to introduce some printf commands. You just need to put points, just like dots. So you can also deactivate them just by pressing them once again. So breakpoints are also a really good feature. You can have control of execution in your hands. So I guess I explained most of the primitive functions, most of the primitive tools available for debugging. There are a lot of tools. It is up to you. You want to check them, you can check them, like parallel watches, threads, or immediate debug mode. So, and autos as well. Autos are just like watches for auto variables, automatic variables. So thanks for watching my video. If you liked my video, please subscribe to my channel. Thank you.